what we looking at? What we looking at? So what we're looking at now are a very similar idea to the empirical equations we've been doing, but now for a practice problem, we're going to look at a curvilinear equation. So it's still an empirical equation where we're putting in numbers into our variables, which in this problem are the boiling point and the air pressure, but the equation itself is not going to be linear. It's not going to be a y equals mx plus b setup. It's going to be some sort of square or root or cube root or something funky. Okay, it's something funky here. So a little bit more math, but it's the same concept. Okay, and the most important thing is I want you to set it up first, show me the work, and then go and put in the actual numerical answers. Okay, so let's just set it up first, and then we'll go get numbers. So an experiment was performed to determine how the boiling point, B, of water is affected by the air pressure, which is P. So this is the air pressure here. Okay? What we're doing is calculating the boiling point when the pressure, P, is at 50 kilopascals. It's a unit of pressure. Okay? So this 50 here is going to go in for the unit, or going for the variable. It will go in for the variable of the pressure, which is right here. That's what it's going in for. It is not going to go in for this kPa. That's a unit. We're not going to add anything to that. That unit is there to describe the 19.7 degrees C per cube root kPa. We want this in for the variable right here. So the setup of this will look as follows. The boiling point will equal our 19.7 degrees C per cube root of kilopascals. Kind of looks weird, but it's just a unit, multiplied by the cube root of 50.0. Okay? Some of you may, because in your math classes you may write this, you might not like to write it as the cube root of 50. You might like to write it as 50 to the 1/3 power. If you like to do that, that's totally fine. That's a great way of doing it. I prefer to do it that way whenever I do my own mathematics, but I know some people are uncomfortable with it, so I write the radicals as well. Okay? If you give me this right here, you just did the problem correctly. Congratulations. You know what you're doing. If you don't get the right answer, that is on your calculator. Okay? That is like, maybe you have a weird calculator, maybe you don't know how to use it, maybe you've never done that before, but if you can set this up, this right here is the physics. This is what I care about, that you put in the 50 for the correct variable. That's all I want. The rest of this is just calculator mumbo jumbo, okay? So let's just do this. Don't forget there is a kPa here. The cube root of the kPa and the kPa down here are going to cancel out, which will give us just degrees C's for the boiling point, which will be nice. So let's actually just try to get a number here. The first thing we're going to have to do with Please Excuse My Dear Aunt Sally and PEMDAS is take the cube root of 50. Now, if you know how to do that on your calculator, if you know what buttons to click, go ahead and do that. If you're like, I don't know what you're doing, then I prefer doing it like this. Type in parenthesis, 50, close parenthesis, big caret, and then we're going to put in 1/3. So parenthesis 1 divided by 3, or 0.333 is fine. When you do that, 50 to the 1/3, or the cube root of 50, you find that this here is equal to 3.68. Since we've got 3 sig figs here, we're going to keep that as 3.68. This is going to be multiplied by 19.7 degrees C. The kPa's, or the cube root of the kPa's, have been gotten rid of. Okay? So now I just need to take 19.7, multiply it by 3.68, and we're good. So 19.7 times 3.68, 72.496. We've got 3 sig figs on both of these, so let's just keep 3 sig figs, and I get 72.5, and my units here are degrees C, degrees Celsius. And that's our final answer. Okay? This here is the setup. This is what I care about. That's the physics. The rest of this is just icing on top of the cake. Okay? So if you get the right answer, congratulations, way to go. I care about the setup though. If you do that setup, you have appeased me You have made me very, very happy. I know you know what you're doing. The rest of it's just calculator. People fat finger buttons all the time. Don't worry about it, okay? And if you're struggling getting those numbers right, like, just don't worry about it. You know, just leave it as it is. Come back later to them, okay? But really, the setup's what we're caring about. When you have to start rearranging this for a later problem, it is a little bit more complicated because you need to get rid of the cube root. Remember, you get rid of a cube root by cubing everything. Okay, so I'll leave that kind of math work to you for that other problem later on. But for right now, we're finished. Take it easy.